Lesson 6-1, Shifting Exponential Equations.
Hello everyone, welcome. I hope you're excited to learn about exponential equations some more. We are finally going to learn what this k is in the exponential equation y equals a times b to the x. Okay, so please take notes, follow along, and enjoy. We're going to learn how to do this. Let's go.
All right, so here is example 1. We have an exponential equation, and so we're going to look at how this graph looks. So we need to make a table of values to sketch the graph and find the asymptote. All right, so we need to plug in the numbers for x. So we can do this in our heads. We can plug in a 2 and do 2 to the second is 4. 4 times 3 is 12. 12 plus 4 is 16. 2 to the 1 now. 2 to the 1 is 2, times 3 is 6, plus 4 is 10. Okay, we have to put in a lot, so if you want to save time and use a calculator, that is just fine. Here we go. Let's do 3 times 2 to the 0. But we know 2 to the 0 is 1. 1 times 3 is 3. 3 plus 4 is 7. I just wanted to remind you that we know 2 to the 0. So let's see. Yep, it is 7. All right, so now you can go up and hit enter on your equation and just go back and change that 0 to a -1. Hit enter. It made it a fraction. Just hit the double arrows and make it a decimal. But we know 11/2 is 5.5. So go ahead and fill in the rest of this table now. We're putting in more and more negative values. I want to put in a whole bunch because I want you to see what's happening. So it started up at 16 and went down a lot, then not as much, not as much, not as much. Okay, so take a minute, put them all in, and let's see what you get. Hopefully you got 4.375 for -3. 4.1875 for -4. It's okay if you rounded it because you're going to have to when you get in -5 for x. It goes on a ways. So let's round and say it's about 4.09. Okay, -6. 4.05. -7, about 4.02. Do you see what's happening? Is it ever going to be 4? Well, let's jump to -10. By -10 it must, right? No. Look, 4.0029. So it's getting even smaller, closer to 4. But that's our limit line. Remember, an exponential always approaches a limit that we call our asymptote. So our asymptote line is 4. And look, that's in our equation too. Usually our asymptote line is 0 when there's no number here, like a +0. But now it makes it our asymptote. Let's graph these points, and I'll show you what I mean. I'm going to put my x-axis here and my y-axis here, since we plotted a lot of negative numbers for x. And then this only goes up to 10, and that's okay. We don't have to graph the 16. We'll just graph when x is 1, y is 10. So we're right there, right on the 10. When x is 0, we're up at 7. -1, we're at 5.5. So between the 5 and the 6. At negative 2, we're at 4.75, so almost at the 5. Then negative 3, we're at 4.375, 4.18, 4.09, 05. It's getting smaller and smaller and smaller, but it never ever will dip down below the 4. So that is our asymptote line. Do you remember how we would make those dotted? Usually on the x-axis. But look, our graph got shifted up. If we were to graph just 3 times 2 to the x, it would be the same equation but down here. Like that, but we shifted it. Let's go ahead and connect our points. There's my exponential equation. So what did the 4 do to the equation? It shifted it up 4, and it made the asymptote 4. The asymptote line 4. Or remember that's the line y equals 4. But this is our asymptote. You can label it. Make sure you have the 2 lines here. You have the curve that's like leveling out because it goes down so small of a time each time. And then we have the dotted line of our asymptote line. Okay, do you all have it graphed correctly? Let's look at the next question. How can you find the y-intercept from the equation? So we know it in the graph it's at 7, but in our equation it is where x equals 0. So we could plug in 0 and find it. So put in 0 for x. So 3 times 2 to the 0 plus 4. 2 to the 0 is 1. What's 3 times 1? 3. 3 plus 4 is 7. So notice, usually our y-intercept is this number in front. That's always our starting amount. But it's not in these equations. It starts at 3, but then the graph gets shifted up 4 more. 1, 2, 3, 4. And now it's up at 7. Okay? So instead of being up at 3, we got it shifted up 4 more. 2, 3, 4. And now it's at 7. So the y-intercept changes from this k. Where's the growth factor? Well, it's where it always is. In our equation, y equals a times b to the x. Now we have a plus k, but we know that b is our growth factor. So the b. So it's the 2. So it's exponential growth. So if we kept doing positive numbers, it would grow faster, faster, faster. But that's not what I wanted you to see. I wanted you to see when we got more negative, what's happening to that line, that it's never ever going to dip below the 4. All right, so that is another exponential equation. That's the only other kind there is. So now you finally know. I'm so excited for you. I hope you're excited too. So let's do this one more time. Let's look at another one. Let's plug in the numbers for x and fill in our table. So this time it's negative 8 times 1/2. You can put in 0.5 if you want. And to the negative 2. If you don't have a calculator at this point, you really should go get one so you can do all this with me. Thank you. All right, so negative 31. Wow, it's a low number. Let's put in negative 1 for x and see what y equals. Negative 15, 0, negative 7. Okay, so go ahead and fill in the table. While you're doing that, I'm going to start drawing my x and y axis so you can see where I decided to put them. I wanted a lot of negative space, so I'm putting my x-axis here. Okay, so you may not be done with your whole table, but hopefully you got negative 3, negative 1, 0, 0.5, or 1/2, 0.75, or 3/4. And then I started to jump by 5 so you can see what happened more. So let's look at those. 0.992, and it goes on and on. So about 0.99. Let's put in 15. 0.9998. So what is it getting closer and closer to? Did any of you say? Wow, 0.99999, and then more stuff. So it's not going up very much, tenths, hundreds, thousandths, by like a 10,000th at a time over 5 numbers. But it's getting closer and closer to 1 whole. Oh, and look, in our equation, it has a +1. There is our asymptote. Okay, so our asymptote's going to be up at +1, and I'm counting by 2, so +1 is right here. All right, so -2, I'm not going to graph that one, and when x is -1, I'm just going to count by 1s on the x-axis. It's easier that way. Okay, so when x is -1, y is -15, so halfway between the 14 and the 16. When x is 0, we're at -7, so halfway between -6 and 8. 1, we're at -3. 2, we're at -1, right there. 3, I'm at 0. 4, I'm at 0.5. Then 0.75, 0.99, 0.999, and it's getting smaller and smaller, but it's never going to hit that 1. So my asymptote's going the other way this time, or my graph is. The asymptote's still straight across. All right, so we graphed our exponential and it got shifted, not very much, just up 1. So that's what the +1 in the equation did. It moved the asymptote up 1. How could you find the y-intercept? Well, we want to plug in 0. I'm hoping you're starting to notice a pattern though, because we know anything to the 0 power is 1. So when we times that -8 by 1, it's going to stay -8. So if I just take -8, but add the shift that we get, the +1, that gives me my y-intercept. My y-intercept, look at that, it's -7. So we're looking for a way to tell from the equation what the y-intercept is. So we're used to it being just the number in front, but when this shifts the whole thing up, so now it's -7. All right, where's the growth factor? It's the 1/2, which means that this is exponential decay. So it's decay because it's going slower and slower and slower going towards the axis. Shifted up 1. All right, so that is what the +k does. It takes your graph that would normally be going up to the 0 line, the y-axis, and it shifts it. If you add, it shifts up. If you take away, it'll shift down. All right, let's write that in our notes. So here is our general equation, and this got C put on here, but most of us call it K. Most textbooks say K, and that's what you've been staring at up on the wall for all these weeks. So go ahead and change it to a +k. So the +k in the equation, it moves the asymptote up or down. How can you find the y-intercept? Well, the one way that works for any equation is to plug in 0 for x, but then we're also looking for a shortcut way. So our shortcut way is to take the a, that's usually the y-intercept. So now you know why I didn't put that this is the y-intercept on the poster on the wall, because it's usually our starting amount, but not when there's a +k. So we can put that it's a plus k. All right, and where's the growth factor? It is the b, as always. Okay, so now that we know the parts of the equation, we're going to use those to graph from just the equation. So looking at this one, f of x equals 2 times 3 to the x minus 2, let's identify the y-intercept and the asymptote line, and then we'll be able to tell how our graph goes. When we know the growth factor, so we know it'll be growth, but we are going to make a table of just 2 more values just to see how things go. 2 or 3 values. All right, so our asymptote line. That's the easiest thing to see because it's the thing hanging on the end there. It's negative 2. Okay, I hope that's what you're starting to see. That's the new part. And the y-intercept is not just the number in front now. We know it's that, but then it gets shifted down 2 from the asymptote, that plus k, so now it's 0. Okay, so we know our y-intercept is 0. The asymptote's going to be down below at negative 2. So our graph is going to be below or above the negative 2. So I know I can make my x-axis here, and that'll give me enough space. So my asymptote is here at negative 2. And I'm just going to put this here. But we could find some more values before we know how high up we want to go. So let's make a little table. At 0, when x is 0, y is 0, that's my y-intercept. When x is 0, y is 0. And then let's plug in a couple more values, one above, one below, and one above. I just picked those randomly. You can pick something different if you want. But let's plug in negative 2. Or whatever you chose. Don't forget the minus 2 when you plug it in. So it's about negative 1.7 repeating. And then when I put in 1, I get 4. And you could plug in 2 if you want, but that got really big. That gets to be 16. And I'm not going to try and fit 16. So if you had picked 2, you could try something smaller, but just make a couple more values because we want to know exactly how this goes. We know it's growth, but we want to plot just a couple more points to make sure how it's going. So at negative 2, we're down at, past negative 1, we're down at negative 1.7, so we're almost to negative 2. Okay? So now we know our curve goes like this. And then we know it's never going to dip down below the line. Don't you love graphing? Graphing's so fun. There's our equation. So you're going to have 6 or so equations to graph on your homework. And then you're going to find the equation. You're going to go backwards. From the information that's given, you're going to try to come up with the equation. So that's our last example. Here we go. Write an exponential equation that matches this criteria or the graph. So here in part A, our growth factor is 7. Well, let's think about our general form, a times b to the x plus k. We know our growth factor is b, so let's plug that in there. 7 to the x. Okay, the y-intercept is 3. We can't plug that in yet because it's not just here, because this is going to shift it. So let's put our asymptote in. Remember, that's our k, so that goes there. Then we know that the y-intercept is going to equal 3 when we take this number and take away 8 from it. So we can think of that as an equation. Go back to what we wrote. To find the y-intercept, do a plus k. And think that that equals your y-intercept. A plus k equals the y-intercept. Let's write that again here. A plus k equals the y-intercept. So a minus 8, that's the plus k, plus negative 8, or minus 8, equals 3, my y-intercept. So what does a have to be in my equation? Add 8 to both sides if you're not sure. But a is 11. So a is 11, then when it gets shifted down 8, then the y-intercept is going to be at 3. So this is it. We are done. You can put in f of x instead of y if you want. Either way. It doesn't matter to me when you write the equations. But that is it. Okay, we're not going to go from the graph yet because that takes a little bit longer, and I'm not sure you're going to have enough time to watch that in the video. So we will go over that next time after Thanksgiving break. So on your homework, that's just number 12. So circle that, don't cross it out, but we're just going to wait on that one. So don't do that one yet. But you can do 1 through 11. So it's just 11 problems, 3 of them are multiple choice, 6 of them you have to identify the parts and graph it. Okay? So that is the homework. I hope it made sense. Work together and help each other if you need to. I hope you have a few minutes to work and do this assignment, and it will be due on Monday when we come back from Thanksgiving. I hope you all have a happy and safe Thanksgiving. Be good. Bye.